Today's lesson is on square roots. So our first vocab word is a radical symbol, and the radical symbol is just the square root sign, the square root symbol. The radicand is the number or expression under the radical. So if you were given the square root of 25, 25 is the radicand. The principal root is the positive square root of a number. So when you take the square root of a number, you actually get two answers. You get a positive answer and you get a negative answer. So the square root of 25 is 5, and it's also negative 5 because 5 times 5 is 25, and so is negative 5 times negative 5. So the principal root is just the positive answer. And then perfect squares are numbers that have whole number square roots. And I made a list of the first 15 perfect squares. They will probably come in handy during your assignment today and the rest of the notes here in the examples that I have for you. So it would be a good idea to write these down and have them somewhere. Example 1 says that we need to estimate the square root of 34 to the nearest tenth. And they want us to do this without using a calculator. So what you want to do is look at that list up here and figure out where does 34 fit in that list. Well, it fits between 25 and 36. So it's between the square root of 25 and the square root of 36. So it's somewhere in here. And it's going to be bigger than the square root of 25, but it's going to be smaller than the square root of 36. Now it's closer to the square root of 36, and that it would be 6, and the square root of 25 is 5. So we know that the square root of 34 is going to be 5 point something. So I'm going to guess and check. Since it's so close to that 36, it's probably got to be 5.8 or so, somewhere in there. So I'm going to try out 5.8, and I'm just going to multiply that together. And I have 2 decimal places, so I have to move this back 2 places. I got 33.64. That is pretty close. I don't think I can get any closer without going over. So the square root of 34 is going to be about 5.8. Next, we have the product property of square roots. And that says that the square root of a product to the product of a square, the square root of a product is equal to the product of the square roots of the factors. So what they're telling us is that we can break up factors. So if I have the square root of 12, I can break that up into the square root of 4 times the square root of 3. Okay, because 4 times 3 is 12. I can do that. And then simplify that into each their own problem there. And the square root of 4 is 2, so that's where this 2 came from. And the square root of 3 is not a perfect square, so to be the most accurate, we are just going to leave it as the square root of 3. So the answer, square root of 12 simplified, would be 2 square roots of 3. Now the quotient property of square roots is the same exact thing, except for it's with division. So the square root of a quotient is equal to the quotient of the square roots of the dividend and the divisor. So in other words, we can take that square root of the fraction and actually break it up into 2 different problems, the square root of the numerator and the square root of the denominator, and then actually do each one and get an answer here. So square root of 25 is 5, and the square root of 36 is 6. So the answer would be 5/6. Example 2 says to simplify each expression. So when you're told to simplify a radical, a number under a radical symbol, you are going to think about that list of numbers I told you to write down from before and try to find the largest number that will go into 50. So the largest number on that list that goes into 50 would be 25. So I can break this up. It's going to be negative square root of 25 times 2. This 25 times 2 would give you the 50 under the radical symbol. So now I can break that up into two different problems. I'm going to have the negative square root 25 times the square root of 2. The square root of 25 is actually 5, so we can't leave that negative sign. We got to remember to bring that over. And the square root of 25 is 5. And then the square root of 2 is not a perfect square. We cannot simplify it. So we write square root of 2, and that's our final answer. Next, we have 2 times 18 under the radical. So we're going to actually do that because 2 and 18, neither one of them are a perfect square. But if I multiply them together, I get 36. So the square root of 36 is actually 6. Example 3, we want to simplify by rationalizing each denominator. And what rationalizing each denominator means is to make sure that we have a whole number in the denominator of our fraction. So looking at this, we have 2 square roots of 2 over the square root of 3. So what I want to figure out is what can I multiply the square root of 3 by so that I get a number that's in that list of numbers I had you write down. In this case, we want the smaller number. So 3 times 1 is 3, that's not a perfect square. 3 times 2 is 6, that's not a perfect square. 3 times 3 is 9, 9 is a perfect square. So that tells me I want to multiply by the square root of 3. And if I multiply the bottom by the square root of 3, I'm going to do the same thing at the top. Because the square root of 3 over the square root of 3 is actually 1, and timesing by 1 doesn't change our value any. So when I multiply the square root of 3 by the square root of 3, I actually get the square root of 9. And then at the top, I have that 2 outside, and then I have the square root of 2 times the square root of 3, which gives me the square root of 6. So I can't simplify down the 2 square roots of 6 any, but the square root of 9 at the bottom is actually 3. So we're going to leave that, and then we're going to have 3 at the bottom. And our next one is 5 square roots of 10. And we want to multiply that 10 by something that is going to be in our list, the perfect square list. And the only number in that list that ends in a 0 would be 100. So in order to get that, I'm going to have to multiply by 10. So I'm going to times by the square root of 10. And if I do it to the bottom, I have to do the same thing at the top. And at the bottom, I'm going to have the square root of 100. And at the top, I'm going to have 5 square roots of 10. And the square root of 100 is 10. And I can't break 10 down. 10 I can break down to 5 and 2, but they're not perfect squares, so we're going to leave square root of 10 there. So I have 5 square root 10 there. Now, notice the 5 and the 10, the numerator and the denominator, are outside of a radical symbol, so that's just like a fraction 5/10. And if you think about reducing 5/10, it's actually 1/2. So I'm not going to write 1 at the top because I already have the square root of 10 there to hold that place. But the 5 would cancel out, become a 1. The 10 would cancel out and become a 2. So then I would have 2 at the bottom, and that is fully simplified. And then for our last example here, we have 2 different problems to do. We need to add or subtract. We have 5 square roots of 2 plus 3 square roots of 2. So if the square root, what's under the radical symbol, is the same, it's just like if it were an x. So picture this saying 5x plus 3x. You would add those coefficients on the outside, and you would get 8x. But instead of x's, they're actually square roots of 2. So this is actually 8 square root 2. And you cannot simplify down the square root of 2, so that is our final answer. For our next one, we have 5 square roots of 3 minus the square root of 12. So I need to simplify this down so that I have the same number under the radical symbol. So 12, I want 3 involved somehow. So I know that 12 is 4 times 3. So 4 times 3 under the radical symbol. The square root of 4 is 2, and the square root of 3 is going to stay. So we actually have 5 square roots of 3 minus 2 square roots of 3. So again, treat those square roots of 3 like an x. So think about 5x minus 2x. You would have 3x, but in this case, you actually have 3 square roots of 3. And that would be your final answer.